also known as beans, have long been a familiar crop to Vietnamese farmers. In the minds of many people, peanuts are associated with soft soil beds, the task of harvesting everything, and the image of farmers bending over to harvest peanuts under the scorching sun. However, in another part of the world, peanut fields are not only a livelihood but also a place where modern technology has completely changed the way people grow, harvest strategies, and process this simple and gentle agricultural product. On peanut fields in the US, field planes with robotic arms, GPS systems that locate accurately to every square meter, and automated production lines that operate around the clock are gradually redefining the concept of peanut farming. From planting, caring, to harvesting and processing, every step is mechanized and tightly controlled by advanced software systems. This not only helps increase productivity, reduce labor costs, but also ensures the quality of peanuts meets the highest export standards. Right from the beginning of the season, the fields have been standardized with bisexual techniques with soil analysis using sensor technology, determining pH, humidity, and necessary natural substances. The Smart Frontline, the system, connected via agricultural software, helps provide abundant and accurate water according to each stage of plant growth. Modern seed planters will sow seeds with deep precision at the required distance, ensuring optimal density for the growth of each peanut plant. The application of high technology in agriculture is not limited to mechanical machinery, but also that includes a series of integrated digital solutions. The Internet of Things IoT system allows sensors placed in the field to continuously collect data on humidity, temperature, wind speed, and light. This data is analyzed by artificial intelligence, AI, to predict pests, focus times, or reasonable analytical advertising. These agricultural weather forecast models are accurate to small areas, helping farmers be more proactive in their production plans. Agricultural drones are also widely used to spray pesticides, monitor crop growth, and map fields in real time. Modern drones are equipped with multispectral imaging sensors, multispectral cameras, allowing them to take pictures of fields under different wavelengths such as infrared, infrared red light, and visible light. Thanks to that, farmers can assess the level of photosynthesis, early detection of stressed areas of plants due to lack of water, nutrients, or pests that cannot be seen with the naked eye. Spraying drones are programmed with automatic flight paths, high precision. The amount of sprayed chemicals is adjusted according to wind flow and password trees. Thanks to that, pesticides are used in the right amount, avoiding waste and environmental pollution. Each drone can spray from 10 to 20 hectares per day, reducing time and labor many times compared to traditional methods. In addition, drones are also capable of creating 3D maps for the entire operating area. From the collected data, the software, a system will analyze low-lying areas, friendly drainage, or places where the soil is too hard to affect peanut growth. This map is used to adjust farming strategies such as changing planting locations, avoiding zoning, or adjusting single targets. More accurately, the central operating system can integrate all data from drones, soil sensors, weather, and machinery in the field into a synchronized digital map, helping farm managers grasp the whole situation of the club in real time. In addition, the platform blockchain has also begun to be applied in the supply chain of the club, ensuring traceability from the field to the table. Each club has a QR code for users to check the consumption and plant information, operating conditions, collected dates, and in the process of conversion. This not only enhances the value of efficiency but also creates trust for domestic and foreign customers when the harvest season comes. Because of mobilizing thousands of workers to work under the sun, only a few machines are needed to operate. The peanut digger, also known as the peanut digger inverter, is a combat aircraft running parallel on the soil bed. The light type digs deep into the ground. The entire club tree and the mechanical arm system will gently lift the stem so that the camel flowers rise to the sky to take advantage of the sunlight to dry naturally. This step alone has saved hours of manual labor and minimized damage. Due to refining after the communication is automatically aired in the field for a day or two, the harvesters will attack. These are machines about the size of a thresher but designed specifically for peanuts. The vacuum system is ready to help clubs from the stalks, filter out sand and organic debris, and then put the seeds into sealed tanks. Each plane can target 5 to 8 hectares per day. With the post-harvest processing process is also optimized thanks to technology. After being collected, peanuts will be transported by specialized trucks to the drying factory. Here, the hot air drying system automatically adjusts according to the input humidity, ensuring that the beans are not overheated and damaged. X-ray scanners, color detectors, and infrared sensors will classify peanuts by size, integrity, and remove broken and moldy beans. Thanks to that, the output products meet high-quality standards, ready for both domestic and export markets. Compared to the traditional peanut production model, the difference is very clear. In many rural areas of Vietnam, peanut growing still relies heavily on personal experience, mainly by hand, and depends on weather conditions. People have to wake up early to pick peanuts, dry them in the sun all day, and then winnow them by hand. These inconveniences not only affect productivity but also increase the risk of mold and reduce the quality of peanuts. Why can't we learn from the American model to change the way we farm? Although we know that investing in modern machinery is a big expense, if we know how to organize production according to the cooperative model, mechanical teams, or rent machines seasonally, then applying technology is completely feasible. A new type of cooperative can own a few peanut digging and harvesting machines, serving the entire production area. Remote agricultural management software can help farmers monitor their crops right on their phones. Processing and packaging centers located near raw material areas will help increase product value and reduce post-harvest losses. Changing mindsets is the first step to transforming production. Farming is no longer a hard job but can be a modern, high-income profession with sustainable export value. We have land potential, a hard-working workforce, and a large consumer market. The problem is just how to connect those links with modern technology and thinking. The machines and the peanut fields in the US are not a fantasy. They are the result of systematic investment, of the thinking of doing agriculture in chains, and of the desire to rise up of tomorrow. In the peanut fields of Phuong or the Central Highlands, automatic peanut tapping, harvesting, and drying machines like in the US appear. It will not only be an image of technical change but also a testament to a revolution in agricultural thinking that is truly beginning. And then, Vietnamese peanuts will not only be a familiar rustic dish, but also an agricultural product with high technology content, competing fairly in the international market. That road is still long, but each step forward today, learning, innovating, to take action will be the foundation.